This video is going to cover simplifying exponents. But to begin, I just want to talk about what exponents are and how they work. So if we have an example that looks like this, 2 to the power of 4, really, what do we have? Well, we have 2 as our base and 4 as our exponent. So what does this mean? It means I'm going to take 2, the base, and multiply it by itself 4 times. And I know 4 times because that's the exponent. Some students want to say, well, 2 times 4 is 8. And they want to try to just multiply these two values. But don't fall victim to that trap. That's not what we're going to do, and that's not how to do it. So, in this case, now that we have 2 being multiplied by itself 4 times, we're just going to go ahead and simplify it and see what it makes. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power of 4 is 16. Well, let's do one more example, just very much similar to that. Let's say I have 5 as my base and 3 as my exponent. Well, I'm going to take 5 and multiply it by itself. How many times? Well, 3 times, because that was our exponent. And now let's just multiply. 5 times 5 is 25, times 5 is 125. So as we have it there, simplifying exponents is a fairly easy process. It gets a little more difficult when we start adding negatives and fractions in, though. But don't let it confuse you. It's pretty easy. Our next example is going to be 1/2 to the power of 3. Well, just like in the previous examples, what did this mean? Well, it means we're going to take 1/2 and we're going to multiply it by itself 3 times. So 1/2 times 1/2 times 1/2. Well, how do we multiply fractions? We go straight across the numerator and straight across the denominator. So 1 times 1 times 1, well, that just gives me 1. And 2 times 2 is 4, times 2 is 8. So 1/2 to the power of 3 is really just going to be 1/8. Well, that's not so bad, is it? Well, let's introduce a negative sign in here. And let's say we have a negative 2/3, and that quantity is being squared. Okay, so since I have these parentheses in here, that means that this squared, the exponent, is going to go to all of this stuff in here. So what am I multiplying by itself? Well, I'm multiplying all of this stuff in here by itself. So I'm going to have negative 2/3 times negative 2/3. And since it's a squared, I just have 2 of them. Well, same as before, let's multiply straight across the top. Negative 2 times negative 2 is 4, and 3 times 3 is 9. Notice in this case that what we began with was a negative, but what we ended up with was a positive. Well, in this case that happens because we had an even number of negative signs, given that 2 as an exponent is an even number, and that's how I know it's going to be an even number of negative signs, which means they're all going to cancel, and I'll be left with a positive number. Well, how does that differ from this? Well, in this case, I have a negative, and let's even put parentheses right there just to help us out so we know this 2 goes to the whole fraction. Well, how does this differ from the previous example? Well, the previous example included the negative when you were multiplying everything by itself. This example does not. So you could read this example as the opposite of 2/3 squared. So the negative is just going to come along for the ride, and it's the 2/3 that gets multiplied by itself. The negative has no business in there except for the fact that he just came along for the ride because he's there out front. So now we have a negative. 2 times 2 is 4, 3 times 3 is 9, a negative 4/9. I'm going to do two more examples that use this comparison idea of saying we have a negative 3, and that's a quantity that's taken to the power of 4. And down here we have the opposite of 3 to the power of 4. So let's kind of do these together and see how they differ. Well, the first one is going to be the quantity negative 3 to the power of 4. So what's getting multiplied by itself? Well, the negative 3 is getting multiplied by itself 4 times. So this negative is in there every single time because he was inside the parentheses, and this 4 went to the whole number, negative 3. So negative 3 times negative 3 makes positive 9. Positive 9 times negative 3 makes negative 27. And negative 27 times negative 3 makes positive 81. Another way we could have done that, probably an easier way, would have just been 3 times 3 times 3 times 3 is 81. And then we have 1, 2, 3, 4 negative signs. And we know that 4 is an even number, so our answer is going to be positive. Well, how does that differ from this? Like a previous example we did, this is just the opposite of 3 to the power of 4. So this 4 exponent has nothing to do with this negative out here. And likewise, this negative has nothing to do with this exponent business. So the negative is just going to come along for the ride. So he's just there. Well, what do I have? I have 4 3's. So 3 times 3 times 3 times 3. I know from the previous example that's going to be 81. And this negative, again, just comes along for the ride. It's very important to be able to notice the difference of these two examples. One where the negative is included in the exponent, and one where the negative is not included with the exponent, and he just comes along for the ride.